Well, it's sort of the simplest possible computer experiment. Run the simplest programs, see how they behave. Well, back in 1981, I came up with particular kinds of programs to try that are known as cellular automata. Okay, so here's how a simple one-dimensional cellular automaton works. One starts with a row of cells, each either black or white. Then the cellular automaton evolves down the page with the color of each cell on each step being determined by a definite rule from the color of the cell and its neighbors on the step before. Well, in this particular case, the rule is really simple. It just says that a cell will be black whenever it or its neighbors were black on the row before. And what happens is that we just get a simple uniform black pattern. Well, we can use that icon at the bottom there to represent the rule, the program we were using. So what happens if we change the rule a bit? Well, now instead of getting just a uniform black pattern, we get a checkerboard. So far, none of this is terribly surprising. We're using very simple rules. We're getting simple patterns out. Okay, let's try another rule. It's the same setup as before. What's going on here, though? We don't seem to be getting any kind of simple repeating pattern. Let's run it a little longer. It gets pretty intricate, but we can see it's very regular. It's just self-similar. It's a self-similar or fractal pattern just formed from nested pieces. And one might think that if one has a simple rule and starts from a single black cell, then one would always have to get a pattern that's somehow very regular, like this. At least back in 1982, that's what I assumed was true.